Hi and welcome to this demo for FRR or free range routing. So FRR is a routing protocol stack for Linux, which is a fork from the Quagga. So those of you that you remember Quagga as a routing stack for Linux. So FRR has additional enhancements to Quagga, which has added more features and more protocols. And in this demo, we will be installing the FRR on our one host machine which we got here. We have a CentOS 7 host. We will be installing the FRR on this host, and there is a router called router 1 at this IP address, and we will be establishing a BGP session to this router. Once we establish the BGP session with this router, we should be receiving this prefix which the router 1 is advertising over the BGP, and we should have it here in the routing table of our CentOS 7 host. In this demo, we will be doing the basic installation of the FRR. We do the initial configuration to enable the BGP daemon inside, and we will access to the VTYSH or the CLI command interface of the FRR, which most of you will be seeing that it's very familiar kind of user interface. And then we do the configuration on the CLI to configure the BGP session with the router 1, and we will make sure our BGP is coming up and we receive this particular prefix from the router 1. Okay, now to start with, let's go to the FRR website, frrrouting.org. This is the website for FRR. It provides some information about the FRR, and also it has a link here for downloading the FRR. So the download takes us to the user guide. If I click here, we get into the user guide section of the FRR. Let's start, looking at the system architecture of FRR. So one of the important features of FRR is that it's unlike the other traditional routing software, which are mostly based on one single routing process. Similar to the traditional Cisco iOS software or the other similar kind of products, where it's just based on one single process, and all the routing daemons and routing processes, they all run as a single process within that single process. Unlike that, FRR is based on multiple different processes which are running in the same system, and we got something called Zebra here, which is like a broker between all of these routing protocols and the softwares. So Zebra here, it gets the routing table, the routes. For example, the BGP daemon is creating, and you're marking them as a route which needs to be installed in the routing table. So these routes from all of these routing processes, from the BGP, from REAP, OSPF, and the others, they all will come to the Zebra, and Zebra finally it injects those routes into the kernel of the machine, or even it can inject them into the routing table or forwarding table of a remote data plane. So here, remote data plane, it can be a data plane like a switch ASIC. So you will be able to use the FRR to control a switching ASIC like a Broadcom Trident, or one of or any other supported switching ASICs, using the Zebra to inject those flows, those routing information into the table of the different switches. So that's how the FRR works. So the Zebra is the routing broker between all of these processes, and for managing all of these processes, we have something called the VTYSH within the FRR, which is like a CLI kind of interface, which allows us to manage the configuration of each of these processes from one single console. So once we do the demo, you will see that it's a very similar kind of CLI interface, very standard look and feel to Cisco iOS. for doing the configuration of the BGP, REAP, or SPF, or creating the other functions like roadmap or the other stuff. FRR is supported on Linux, FreeBSD, NetBSD, OpenBSD, also on Solaris, macOS is all supported. The support for different modules is different on the operating systems. For example, let's say the VRFs. VRF, for those of you who are not familiar with VRF is a technology to create virtual routing tables inside the systems. So a system can have multiple routing tables, but they are all isolated from each other, and only those interfaces and processes who are running on that particular routing table will be able to use and see those routes. And so VRF is supported in Linux from version 4.8 onwards. That is supported. And yeah, and the other protocols like MPLS is supported on Linux, supported on OpenBSD, but not the others. Policy-based routing is only supported on Linux. BGP is supported on all the platforms, all of these operating systems, and so on. So these are all the supported available protocols or features within the FRR. For installation of the FRR, if you can just click here on the installation. The project, it published the packages for Red Hat, CentOS, Debian, and they are all available on the GitHub release. So if I go to the GitHub release of the FRR, here we will be able to see the ready-made packages for FRR. So for example, this one, this is for CentOS and Enterprise Linux 7, which is the one which we are looking for, and we will be downloading and installing this one. So we just need to download and install this RPM package to our system. And also, here in the GitHub, they publish the packages for all the other operating systems also as well, for Ubuntu, Debian. There are so many of them here. So you just need to find your flavor of the operating system and download and choose the correct installer, and we will have the FRR running. Also, it provides information that how we can build and compile the FRR if you need to do any customization, especially if, for example, if you are planning to use MPLS. MPLS requires some kernel changes on CentOS, for example. So probably you will need to do a recompiling of the kernel for supporting of the MPLS. For basic setup of FRR, so once we do the installation, the first step is we need to edit this file /etc frr daemons. So daemons, this file, it lists down all the daemons which we have in the FRR. So by default, all of them are disabled. And to start with, once we do the installation, we will enable Zebra and we will enable the BGP daemon, because that's the Zebra is the main thing, the broker. We have to enable that, and the BGP daemon also we will enable that as well. Once we change the daemon, we just need to do a basic do a restart for the FRR to make it happen. And after that, we should be able to get access to the VTY shell of the FRR. And VTY shell, as I said, it's like a CLI for all of these daemons. Once the daemon is enabled, we can use the VTY to do the configuration. Now let's start with downloading this particular package. We'll copy the location and we will do SSH to our host here, and we will continue the installation from there. All right, so now I got the console. Let me connect to the host which we have here, this one. So I will connect as root at 192.168.211.151. I got the SSH keys and I don't need to do any password authentication, so I got root access here. And okay, so I copied that. So let me just do RPM -i and the address which we copied from the GitHub. So this command will download the FRR from the GitHub, and it will install it as a package here on Linux. So it looks like it is downloaded and installed. Let's check that. We query the RPM and we see if the FRR is installed. Yep, so FRR version 6.0 Enterprise Linux 7 or CentOS has been installed already. We can start the service by issuing the command systemctl restart. So if this stopped, also if this already started, it will restart the service FRR, and it's done. So by default, if I do a vtysh now, nothing will happen because we don't have the daemon running. So I need to edit the file which we saw, which we got here. You know, if you remember, in the basic setup, we have to edit this file /etc frr daemons. So let's go here and we say /etc frr and daemons. So now we are within this file, the daemons file. Let's see. Okay, here we go. So we have to enable Zebra and we have to enable BGP daemon. We can enable OSPF version 6 for IPv6, RIP, ISIS, these are for MPLS, PIM for multicast routing, EIGRP also is supported, and the other protocol as well as the static routes, that's also supported here. And I save this file and I will do a restart again of the FRR. Okay, so now if I issue the vtysh, here we go, it says hello, this is FRR routing. So I got something similar to, you know, this is the host name and we got a new command prompt. So if I do a show running config, give me the running configuration of this host right now. And you know, it's just the look and feel at, you know, like a Cisco iOS. You know, you got lots of show commands, you have tab to complete the command, and if you put the question mark also, it gives you all the information. I can do show interface, you know, list. It shows me that, you know, the interfaces which we have a loopback interface and we have Ethernet 0 interface, the IP address of that interface, and so on. So now let's start doing the configuration for the BGP as we wanted. But before that, let's try to ping the other host which we have, which is this one. Let's make sure they are both on the same layer 2 network. But will I be able to ping? Yes, I will be able to ping that. Okay. Yeah, and I will put the IP address of that machine, that router 192.168.211.152. Yeah, I am able to ping that that machine. So we can do the very basic configuration for the BGP. We say router BGP and AS number. Let's look at our drawing. AS number is 65,000. 65,000. And here we can just do neighbor. Our neighbor address is 192.168.211.152. Let me make this a little bit smaller so we can also have a look at our drawing. Okay, and the remote AS for that router is also AS number 65,000, so it's just an IBGP connection between these two. Let's do a network of our current network, which is 192.168.211.0/24. Can do ends, and let's see what has happened. Let's check out our running configuration. As you can see here, the configuration is very similar again to the industry standard configurations. And okay, now let's see, show IPBGP. Can do a show IPBGP summary. So here it says we got a neighbor here 192.168.211.152. This is the router 1 with a 65,000, and we have received 6 messages. We sent 4 messages, and it looks like the session is off for 1 minute and 26 seconds as of now. It looks like we have received 2 prefixes as well, and we can do show IPBGP neighbor. let's say the same neighbor, copy and paste. We can say received routes. Soft configuration is not enabled, so that's fine. Show IP BGP okay, show IP routes of BGP. So here, as you can see, we have received this particular prefix 5.5.55 from our BGP neighbor, and that's what we wanted to achieve. So we are receiving that particular route from over the BGP from router 1, and we should be able to ping this particular IP, ping 5.5.5, and we can ping that IP. So this is the VTYSH, I mean the shell access for FRR. And you know, again, if I do show run, you know, you will see the configuration. Yeah, I think we can do a write mem to save the configuration, and here we go. You know, it says that the configuration is saved into the zebra.conf and the bgpd.conf. Let's have a look at there. So if I exit from here, I'm back on the Linux shell. Let's see what's going on inside /etc frr zebra.conf. So zebra.conf, these are the basic commands for the global commands. It looks like it's being saved here in the Zebra. So host name, no IP forwarding or IPv6 forwarding, these commands are located here. And if I do for the BGP, I'm expecting to have the BGP configuration to be here. So again, the host name is set inside the BGPD, inside the BGP daemon, and the whole BGP configuration is also located here. If I do route -n, and here is the host machine routing table. So this particular route, as you can see, is already installed in the routing table, the 5555, and the gateway is the router 1. So this route actually is installed by the Zebra. So Zebra got this information from the BGPD that, hey, I got this new route, and this route has to get installed in the routing table. And Zebra by default, it installs in the host routing table. You can enable the other features, the other protocols. You know, it's a complete full-fledged routing software. You can do anything with it. You can do lots of policy-based routing, which makes it very, very flexible for doing all kind of customization, or mostly actually you can use it, you know, as a handy BGP or, you know, OSPF routing daemon tool. All right. Now this question may come to you that, you know, why do we need routing on a host? So the answer is that, you know, you can just create the FRR. You can use FRR to create Linux-based virtual router. That's a very easy way of creating virtual routers. You know, you can have many interfaces, you know, virtual interfaces connected to your virtual routers. When you run the FRR on a virtual machine, you can have as many as you want VLAN interfaces, you know, connected to the virtual router for doing and performing different kind of functions, especially when you need to do and create virtual networks within the host, between the virtual machines, you know, isolated from the real networks. You know, that will be really helpful for using the FRR. Also, you can use FRR to add the routing intelligence to the compute host. So for example, you got if you got servers running KVM or, you know, other hypervisors, and, you know, by default, the Linux hosts, they just do the layer 2 switching to send traffic to the upper router, to the next hop router. So the virtual machines, normally they just route the packet out to the default gateway, which is normally outside of the Linux host. And so in order to, for example, to provide if you got multiple physical interfaces from your compute host to the top of the rack switches, and you need to run kind of routing protocol between the Linux host and the switch, you can utilize all of those interfaces. For example, if you are using BGP or if you are using OSPF, so you can use the ECMP features, equal cost multipath features of these routing protocols to very efficiently utilizing all of these links instead of using the bonding or link aggregation using LACP. That will be really helpful. Also, if you run the containers and you have multiple virtual networks, layer 3 networks within your host, within your compute host, by using a routing stack like FRR on the host, you will be able to advertise all of these subnets which you got to the upper router, and you will be able to create a full reachability between the container networks within the host and the outside network. So you don't need to do any kind of NATing, which are sometimes become like overhead. And of course, you can create low-cost test labs for doing the testing of almost anything using the FRR. So FRR is very handy. Probably, I think most of you, you might be familiar with Zebra or Quagga. You have tried it before, and the FRR is just a newer version and enhanced of the same software, providing the same software but with more additional features like supporting the MPLS and other stuff. Please feel free, if you have any question or any requirement for additional demonstration, please feel free to write in the forum, or you can contact me directly. Thank you.